In this video, I'm going over a stellar evolution of stars in the universe. It all starts with a molecular cloud, which is a type of nebula, which has a high density and a very low temperature, which combines to make a gas called molecular hydrogen. Along with cosmic dust, that's what it's made of. When gravity exceeds the outward push of gas, the pressure is too strong that starts to collapse because of shock waves from a near exploding star. Or if another molecular cloud collides with it, then it starts to split into smaller clouds, which creates a protostar, which is the next stage of a star. A protostar is the beginning of any star. Their cores aren't hot enough for fusion to occur. The first thing it does when it exits its molecular cloud is that it starts to spin until a disk forms around it. As the disk rotates, they produce a strong magnetic field, which pulls gas and dust into the core, and the infalling gas releases some kinetic energy, which increases the temperature by creating heat. At this point, it can be a hydrogen-burning star. This is when the nuclear fusion starts in a protostar, which brings us to our next stage, which is a T-Tauri star. T-Tauri stars are also known as pre-main sequence stars. This is when it starts to clear the gas and dust away from the star. The stellar winds that are sending the gas and dust away are called bipolar outflows. That's when the mass decreases and it becomes a main sequence star. That's when it can start burning nuclear gas. So now it can start burning hydrogen for at least billions of years. Stars come in different sizes, so their lifespans are different. Smaller ones are longer lives, bigger ones have shorter lives. We'll start with the lower mass stars like our sun that have longer lives. As they use up their hydrogen core, they will expand into a red giant star. The next step is after the red giant star sheds its outer layers away, they throw off gas and dust, creating a planetary nebula, which is housing a white dwarf core remnant. And planetary nebulas get their name because they look like a planet through a telescope. Eventually, all the gas will fade away and all that's left is the white dwarf star. It's the third densest object in the universe. White dwarf stars are equipped with the sun's mass but have a diameter the size of the Earth. After it burns out, it becomes a black dwarf star, which is all that's left after a white dwarf cools and burns out completely. Now are the larger stars that have much shorter lives. As they expand into a red supergiant star, they begin to fuse heavier elements, and that's until the core turns iron, so that's when the star runs out of fuel. And that's when it supernovas, and supernovas are about the size of full moons in our night sky. It will either leave behind a neutron star, which is a giant star's collapsed core tightly packed with neutrons that spin rapidly that have beams of radiation, or a black hole which has infinite gravity and mass density. Nothing, not even light, can escape it. Videos for most of these objects will be in the link in the description.
Make sure to like and subscribe. Thanks for watching.